Good evening, guys.
Good evening, sir.
So last class we were doing a problem, right, based on three lenses in combination. Now we'll go to the next concept, that is the concept of refraction through prism. Okay. So basically we have to understand what a prism is. So prism is basically a refracting medium or a refracting material with both sides of planar structure. So if I take a material like this, right, this side and this side is the way the light is going to travel and undergo refraction. So if you observe, both these surfaces are planar in nature. Similarly, I have third and fourth. If you take these two surfaces, they are planar in nature. So if you ask me a question, can I call this as a prism? The answer is yes. Yes, I can call it as a prism, and I'll give a prefix to it, which I will call it as a rectangular prism. In a similar way, if I think of a surface like this, right, where this is the first surface and this is the second surface, both are of planar structure in nature, then this kind of a prism is what we call it as triangular prism, right? And our topic of discussion is going to be restricted with respect to a triangular prism. This rectangular prism is what we technically called it as a glass slab also. And we have seen how this glass slab would refract the light that is passing through it. So when I take this triangular prism, we can say that when light is hitting the first refracting surface, at this point of incidence, I can draw a normal, where I'll call this as the angle of incidence. So the ray will travel like this, right? So between the actual path and the normal, the ray will get refracted like this because it is traveling from rarer to denser medium. So at the second point of incidence, we can observe that if I draw a normal at this point, then the ray is supposed to travel like this, but it will travel away from the normal because it is traveling from the denser to the rarer medium. So if I join these two normals, they meet at a point. So let me say this is A, B, and this is C. And the point of intersection of these two normals, I'll call it as F. This is D and E. Okay. And this angle A is what I call it as the angle of prism or the apex angle. Okay. Now listen to this carefully. This is point E. So this will be R1 and this will be R2. That is the angle made by the refracted ray inside the prism is making an angle R1 with the normal on the left hand side and R2 with the normal on the right hand side. And this is going to be the angle of emergence. Okay. Now, if I take the triangle DEF, so DE is like this, F is like this. This is R1, this is R2, and if I take this angle, this will be 180 minus of R1 plus R2. So this is D, E, and F, right? So angle F is going to be 180 minus R1 plus R2. Similarly, if I take the quadrilateral ADFE, then A is like this, D is like this, A is like this, E is like this, and F is in this way. Angle D and angle E are 90 degrees. Observe. Angle D and angle E are 90 degrees. And this is angle A, and this is 180 minus of R1 plus R2. A, D, F, and E. Now listen to this. A plus this angle 90 plus this angle 180 minus of R1 plus R2 plus this angle 90 degrees all put together is equal to 360 degrees. So 180 plus 90 is 360. So A will be equal to R1 plus R. Okay. So the relation between the angle of prism and the two refracting angles within the prism is equal to this thing. Angle of prism is equal to sum of the angles of refraction, R1 plus R2. Okay. Make a note. Done? No.
Sir, just 1 minute, sir.
Yeah, right.
So can you? Yes.
You're done? You're done? Listen.
Yes, sir.
So this is the extended incident ray, and this extended emergent ray, I'll push it backwards. Then the angle through which the incident ray was traveling like this, but the emergent ray has come out like this. Means the incident ray has taken a turn in the anti-clockwise direction through an angle delta. Okay, through an angle delta, and this angle is what we call it as angle of deviation. What is it called as? It is called as the angle of deviation. Okay, so what is going to happen? I'll redraw the diagram. See, if I take this as the prism, this is the emergent ray, this is delta. See, this angle is I, this whole angle is also I, and this is R1. If this angle is E, this whole angle is E, and this is R2. If I join them together, we know that this angle is 180 minus of R1 plus R2. Right? Now, if I take this point as G, and this point is already D, and this point is E, if I take the triangle GD and E, it is going to be something like this. So if you observe how much is this angle, how much will you say? This angle, and how much is this angle going to be? So this is I minus R1, and this is E minus R2, and this angle is delta. So we can say that exterior angle is equal to sum of opposite interior angles. So delta will be equal to I minus R1 plus E minus R2. This can be written as I plus E minus of R1 plus R2. But what is R1 plus R2? R1 plus R2 is A. So this will become I plus E minus A. So delta is equal to this value. So delta is equal to the angle of incidence plus the angle of emergence minus the angle of the prism itself. Okay, make a note.
So can you show the prism? Oh, okay. Sir.
Done. So the
Yes,
two
sir.
important formula that we are supposed to remember is A is equal to R1 plus R2 and delta is equal to I plus E minus E. Okay. So having these two concepts in mind, now we are going to come across a new term called as the angle of minimum deviation. So angle of minimum deviation, I will call it as delta with a subscript M. Okay. So let me explain what is the meaning of this. If you observe, I is independent. Independent in the sense we have the control over it. The angle of prism is independent. Okay. E is dependent. In the sense, the angle of emergence cannot be controlled by us. So angle of incidence, angle of prism is under our control, but the angle of emergence is completely dependent on what input value you are going to give. Okay, so having said all these things, what we are going to do is if you perform an experiment, let's say, if you perform an experiment in such a way that, let's say, you want to start with this angle. So you want to have the incident ray like this, where theta is equal to 90 degrees. That is the angle of incidence is equal to 90 degrees. Okay. And you keep increasing the angle of incidence, then there will be a change in the angle of emergence also that is going to take place. So during this process, what is going to happen is you can observe, if you tabulate all the values, angle of incidence, angle of emergence, and delta, As the value of angle of incidence is changing, angle of emergence will change, as a result of which delta will also change. And in those values, you can find one particular value of delta, which will be the least. Okay. So when you have that least value that is occurring, one important observation that you need to make is the angle of incidence and the angle of emergence will be equal in that scenario. And that is a scenario where the incident ray is said to undergo a minimum deviation. Okay. So at that scenario, I'll tell you how the diagram will look like. It looks something like this. So if this is the incident ray, then the ray will bend towards, the ray will get bent in such a way that the refracted ray inside is going to be parallel to the base. Okay, refracted ray will be parallel to the base. This will be R and this will also be R. And this kind of a ray is said to undergo symmetric refraction. So the ray here you can say that it has undergone symmetric refraction where the angle of incidence is equal to angle of emergence and R1 is equal to R2 is equal to R. So what happens here is the refracted ray will be parallel to the base. Okay. So if I extend this ray and if I extend this ray in backward direction, then this angle will be the angle of minimum deviation. So we know that delta is equal to I plus E minus A and A is equal to R1 plus R2, right? So during minimum deviation condition, I can say delta M is equal to I plus I minus A, which implies A will be equal to 2 times I, sorry, where I will be equal to A plus delta M divided by 2. Okay, because this is going to be 2I minus A, this will be delta M. Bring A to the left hand side. So A plus delta M is equal to 2I. So I will be equal to A plus delta M divided by 2, which I'll call it as equation number 1. Similarly, A will be equal to R1 plus R2, but we know that R1 is equal to R2, which implies A will be equal to 2R. That is, R will be equal to A divided by 2. Let this be equation number 2. So you can ask me, what is the advantage of me knowing the angle of incidence and the angle of refraction? The advantage here is whenever you are asked to calculate the refractive index of the material, at that point, what you can do is you can apply the Snell's law at any one of the boundary and find the refractive index of that material. So the refractive index of the outside material is 1 and the refractive index of the inside material is mu. So applying Snell's law at this boundary, I get 1 into sine I will be equal to mu into sine R, which implies mu will be equal to sine I divided by sine R. But what is sine of I? I is A plus delta M divided by 2 and sine of R is going to be A divided by 2. So this is going to be the formula which we are going to apply for the refractive index or finding the refractive index of that material. Okay. So make a note of this. So let me know once you're done writing this. Done?
Yes, sir.
So next concept that we are supposed to see is this graph. So when you plot the graph between the angle of deviation and the angle of incidence, the important thing that we can observe is the angle, as the angle of incidence is increasing, the angle of deviation will keep decreasing. The angle of deviation will keep decreasing till a certain value, after which again the angle of deviation will increase. So there will be one particular position of angle of incidence which you can find by taking the lowermost point in the graph and dropping a perpendicular onto the x-axis, at which the angle of incidence will be equal to the angle of emergence. And from here, if you drop a perpendicular onto the y-axis, then this will give you the angle of minimum deviation. Right. So there is only one particular angle at which there is one deviation, and that is possible only when I is equal to E, where you will have angle of minimum deviation. Whereas if you see at any other point, what will happen is there will be two particular angles of incidence at which there will be the same angle of deviation taking place. So I repeat, there will be two angles of incidence at which, or I can say there will be one particular angle of incidence and one particular, the angle of incidence and angle of emergence will adjust in such a way that there will be one particular angle of deviation. Okay. Next is dispersion through prism. There's not a new concept here. Right? Dispersion by prism. So what is going to happen here is, you know, what does a white light consist of? So white light basically consists of 7 different colors. So when you pass white light through a prism, what is going to happen? The rays, when you pass white light through the prism, the white light gets split into 7 constituent colors. And why is this happening? It is happening because each color has a different wavelength associated with it, and each wavelength will affect the refractive index of the material, due to which there is different kinds of angles of deviation taking place for each color. Okay, so this kind of a phenomenon where the white light gets split into its 7 constituent colors is what is called as dispersion of light. And the dispersion is exhibited by a material called as prism, which is a triangular prism basically. And all these colors put together is what we call it as spectrum. Okay, so this is the basic concept. And the next important observation that was done is by Newton only. So the observation is, when you keep the prism upright, when pass white light through it, then the white light gets split into 7 constituent colors. If the 7 constituent colors are passed through a subsequent prism which is kept in an inverted position, then what is going to happen? The colors will again join back and the white light is going to be produced. Okay, and this is there's one of the ways by which you can obtain back the white light. Okay. Next is some natural phenomena that are associated. This is from your 10th standard. One is the formation of rainbow. The second is scattering of light. So these two concepts, I'm leaving it to you. You guys can read it. Okay, it's a theoretical part. So today's concept that we mainly concentrated upon is how a prism is going to refract the light which is passing through it, and one important phenomenon that is exhibited by it, which is dispersion of white light, right? So having all these points in mind, we are going to solve some problems that are based on this concept. So let's try them. Okay. Okay, listen. First, so try this problem. There is a ray of light which is incident at 45 degrees on the face of an, which is incident at an angle of 45 degrees on the face of an equilateral prism, which passes, and the light ray passes symmetrically. Calculate the refractive index of the material of the prism. Now, who can explain me the values? First, a ray of light is incident at an angle 45 degrees. So what is the angle of incidence?
So 45 degrees.
45 degrees. On the face of an equilateral prism. Equilateral prism means the angle of the prism is
60 degrees.
60 degrees. It passes symmetrically, meaning angle of incidence is equal to the angle of emergence. And when is this possible? Only when the minimum deviation condition is right. What is the objective in this problem? Our job is to find the refractive index of the material. So what is the formula for refractive index? Mu is equal to sine of a plus delta m divided by 2 divided by sine of a by 2. Correct? So mu will be equal to sine of, what is a? It is 60 plus what is delta m? Delta m is I plus e minus a. So here I and e are same. So both are 45. So 45 plus 45 is 90. 90 minus 60 is going to give you 30. So 60 plus 30 divided by 2 divided by sine of a by 2. A by 2 is 60 by 2. So sine 45 divided by sine 30. So how much is it? Mu is equal to sine 45 divided by sine 30. So sine 45 is 1 by root 2. Sine 30 is half. The answer will come out as okay. Next. I hope this problem is clear, right?
Yes, sir.
Look at the second one. I want you guys to try this. There is a ray of light that passes through an equilateral glass prism. First, draw an equilateral prism so that the angle of prism is how much? 60 degrees. Okay. I hope you drew it in such a way that the angle of incidence is equal to angle of emergence. So what is the meaning of it?
Symmetrical.
It is symmetrical. Again, a minimum deviation condition. Now, they have told if the angle of emergence is equal to 3 by 4 times the angle of the prism. So it is 3/4 of angle of prism is 60 degrees, which is going to be 45 degrees. Okay, when this is going to be the case, our job is to again find the refractive index of this glass prism. So how to do this?
Sir, we need to find the minimum deviation.
Yes, how much is the minimum deviation? Delta m is equal to 2 times I minus a. So 2 into, we know that I is equal to e. So that is 45 minus A is how much? 60. 90 minus 60 is again going to be 30 degrees. So in this problem, I is 45 and delta M is 30. So you know the formula for refractive index. Mu is equal to sine of, what is the formula? A plus delta
A
M divided
plus delta divided
so
by
A
sin A.
60 plus 30 divided by sine of A by 2. A is how much? It is again going to be 30. So 60 plus 30 divided by 2 is sine 45. So sine 45 is 1 by root 2 divided by sine 30 is half. To give you. So actually speaking, this problem and the previous problem are the same, except the fact that previous problem they gave you the values directly. Here they gave you the values indirectly. So there was some hidden information. Clear? Right. So those who are making a note of it, please write it down. So let me know once you're done.
Done, sir.
Done. Let's try the next one. So there is a ray of light which is incident. 1 minute. Just give me a minute. You guys read the question. Ray of light. Okay. So third one. There is a ray of light which is incident normally on one of the faces of prism of apex angle 30 degrees and refractive index of root 2. Find the angle of deviation of light. So did you understand the question? How many of you solved this? So listen to this. So I have a prism. A ray of light is incident normal on the surface. So what is the angle of incidence?
90 degrees.
Normal means along the normal. Along the normal, angle of incidence is 0, which implies R1 is 0 degrees. right? Means it will go without any deviation, and it is going and hitting the surface on the other side. Now the refractive index of this material is √2. Find the angle of deviation of light. So this is the actual path of the ray, but since the ray is traveling from denser to rarer, it will bend away from the normal. So this will be the angle of emergence, and this will be the angle of deviation, because angle of deviation is the angle between the actual path and the emergent path. So this will be the angle of deviation, correct? Now the question is, if R1 is equal to 0 degrees, then the angle of prism is 30 degrees, that is given. Then what is the value of R2? So we know that A is equal to R1 plus R2, which implies 30 is equal to 0 plus R2, and R2 is going to be 30 degrees. When R2 is 30 degrees, can you apply Snell's law? So √2 times sine 30 degrees is equal to, the outside medium is 1 into sine E. So √2 into sine 30 is half, is sine E, which implies sine E is equal to 1 divided by √2. What is the value of E? It is 45 degrees. So the angle of deviation, the angle of emergence is 45 degrees. Right? Angle of emergence is 45. And this R2 is 30 means this will also be 30 because vertically opposite. From 45, 30 is gone means what will be the angle of deviation? It will be 15 degrees. Is that clear? Is that clear, guys?
Yes, sir. Sir, can you show those steps? No?
Yeah. So copy the diagram properly. You try to draw it on your own. If you have any doubt, ask. Done? Can we try the fourth one? So there is a ray of light which is incident on the face AB of a glass prism ABC. ABC having vertex angle 40 degrees. So this is 40. The face AC is silver. The face AC is silver. And the ray of light is incident on the face AB such that it retraces its path. Means what is happening is the ray is incident on the surface in such a way that the ray gets bent in such a way that it is going to hit the surface perpendicular. Because we know with respect to reflection, what should happen? right? With respect to reflection, what should happen? When the angle of incidence is 0 degrees, the angle of reflection will also be 0 degrees. Right? When this is going to be the scenario, our job is to find what is the angle of incidence for this kind of a process to take place. So if the angle of incidence is I and I call this as R1, what is the value of R2, guys?
180 minus 7.
No need. R2 is 0. Because R2 is the angle of incidence on the second refracting surface. It is falling normal to the surface. Because read the statement, it retraces its path. Retrace will happen only when the angle of incidence is equal to the angle of reflection is 0 degrees. So R2 is 0, then R1 will be 40 degrees. Simple. Right? Because A is equal to R1 plus R2. So this is going to be 40 degrees. So outside medium is 1. 1 into sine I is equal to 1.54 into sine 40. So calculate this. I will be equal to sine inverse of 1.54 into sine 40 degrees. So this will be the answer. Okay. Did you understand what I did?
Yes, sir.
Next. Prism of refractive index 1.53 is placed in water of refractive index 1.33. If the angle of prism is 60 degrees, calculate the angle of minimum deviation in water. So prism of refractive index 1.33. So refractive index of prism is 1.53. Refractive index of water is 1.33. If the angle of prism is equal to 60 degrees, our job is to find the angle of minimum deviation. So refractive index of prism with respect to refractive index of water is equal to sine of A plus delta M divided by 2 divided by sine A by 2. Did you guys understand what is the difference? In the previous problem, refractive index of the prism divided by air medium was sine of A plus delta M by 2 by sine A by 2. Now the outside medium is water. So it is going to be 1.53 divided by 1.33 is equal to sine of A is 60, 60 plus delta M divided by 2 divided by sine 30, which is going to be half. So which implies sine of 60 plus delta M divided by 2 is equal to 1.53 by 1.33 into half. So 60 plus delta M by 2 is equal to sine inverse of 1.53 divided by 1.33 into half. So 60 by 2 is 30. Delta M will be equal to sine inverse of 1.53 divided by 1.33 into half minus 30 degrees. Clear? So you need not calculate these values. It is only for your practice. Okay. They'll not ask you this tough problem and all. It will be simple only, but it's better we practice some tougher problems. right? So we'll do one more problem. Try the sixth one. Try the sixth one. So there is an equilateral glass prism whose refractive index is 1.6, is immersed in water of refractive index 1.33. Calculate the angle of deviation produced by a ray of light incident at 40 degrees on one face of the prism. So this we can't do for this. Let's leave this. Let's try seventh. So there is a ray of light which is incident at an angle of 60 degrees on the first face of a prism of angle, of an angle 30 degrees. The ray emerging out of the prism makes an angle 30 degrees. The ray emerging out of the prism makes an angle 30 degrees with the incident ray. Okay, as shown in the figure. Show that the emergent ray is perpendicular to the face through which it emerges out. Also calculate the refractive index of the material. So what they are trying to say is, we need to say that the angle of emergence is equal to 0 degrees. If you are able to prove that, then you can say that the emergent ray is perpendicular to the surface. Can you do that? So read the question carefully, okay? So there is a ray of light which is incident at an angle of 60 degrees on the first face of a prism at an angle, a prism of angle 30 degrees. The ray emerging out of the prism, makes an angle 30 degrees with whom? With the incident ray as shown in the figure. Okay. Show that the emergent ray is perpendicular to the face through which it emerges. Also calculate the refractive index of the material of the prism. It is a very, very, very simple problem. It is just one step. Let me see who is able to solve this. It is very, very simple. Simple geometry will give you the answer. Anybody who cracked it? It's very simple. See, if this angle is 60 degrees, vertically opposite angle, this is also 60 degrees. Okay, if this is 60 and this is 30, this is how much? This will also be 30. So R1 is 30, A is 30, and R2 is how much? That's what we need to find. So A is equal to R1 plus R2, 30 is equal to 30 plus R2, which implies R2 is equal to 0. When R2 is equal to 0, what will be the angle of emergence? That will also be 0. When that is 0, what can you say? Emergent ray is perpendicular to the face. Perpendicular to the face through which it emerges out. Also, you need to calculate the refractive index of this material. So for you to calculate refractive index, what you need is the angles. So 1 times sine 60. So 1 into sine 60 is equal to mu into sine of R1. R1 is 30 degrees. Okay, sine 60 is root 3 by 2 is equal to mu into sine 30 is half, which implies mu is equal to root 3. So refractive index of this material is root 3. So these are all the problems that are based on Prism concept. Okay. So in the next class, we'll discuss about optical instruments, and then by Wednesday, we'll try to close this chapter. And from Monday, I'll start wave optics. Okay. So that's it from my side for today. Any other doubts?
No, sir.
Okay. We'll wind up.
Thank you, sir.
Thank you, sir.